So it's really clear we've got to decarbonize all sectors of the economy by 2050, by mid-century. Transportation is the most difficult sector to decarbonize because it has to carry its energy with it. The emphasis of the laboratory is really on renewable energy generation. So our mission is about taking renewably generated electrons and allowing us to move people and things from point A to point B using those renewable electrons, right? So we've got basically three ways we can do that. We can use the renewable electrons directly in battery electric vehicles. We can use those electrons to make green hydrogen and use that hydrogen as a fuel for vehicles, primarily heavy vehicles. Or we can use those electrons as an energy source into the processes that can convert biomass into zero carbon liquid fuels. And so we've got to understand, how do people interact with these technologies? How do they adopt the technologies? We can already see that electricity generation is on a positive trajectory, right? It's getting lower and lower carbon.
We're trying to get the cost of hydrogen down through hydrogen production, primarily through electrolysis. So basically taking electric inputs like renewables, nuclear, fossil with carbon capture and sequestration, basically making electricity, clean electricity, and then splitting water through electrolysis. So water's H2O, you split it, you end up with hydrogen and oxygen. That hydrogen then can be stored. It can be blended into the natural gas pipeline. It can be used directly as hydrogen in vehicles, cars, trucks, buses, trains, ships. So a lot of different applications of hydrogen over on the end use side, all coming and originating through clean electricity.
So probably one of our greatest achievements so far is creating a high-flow hydrogen station facility. And so that facility is designed to test and prove out high flow rate hydrogen fueling for heavy-duty vehicles. The work that we're doing will contribute to kind of the base level research and development that's required for developing hydrogen fueling protocols for heavy-duty vehicles.
So NREL is really investigating the decarbonization of transportation across all sectors, including both the light-duty, medium-duty, heavy-duty industry, and even some off-road transportation options. And one of the biggest considerations with this is not only the adoption of the vehicles themselves, but also the charging requirements for these vehicles. How will we get the energy on board the vehicles from the grid that they require? We're considering aggressive adoption rates, looking at what would medium-duty vehicles, heavy-duty vehicles look like at scale of adoption, and what would their energy needs be based on their existing travel requirements.
We have work across this laboratory in wind and solar and other activities, and so we really view ourselves as a system integration laboratory. And when we look at the merge of the electric transportation and grid industry, we're kind of in the center point of how these vehicles could interact with these intermittent renewables. As we see this evolution of and transition to electric vehicles, there's going to be a significant new load that's going to be needed to be supplied by the grid.
The research we're doing here is looking at how can we make the grid more amenable to a large electrification load, and what are the technologies that can help make sure that this deployment of large-scale electrified vehicles will not cause problems and perhaps even potentially benefit the grid. ARES is a platform to allow us to look at real-world systems at very high power levels that represent the kind of power levels we'll have in the real world. So this allows us a way to look at what happens when you plug in 10, 15 vehicles all requiring power at the same time. This kind of facility does not exist anywhere else in the world. And the research that is being carried out here is really blazing the trail for how we can provide these new mobility solutions related to high-power charging into the market quickest and in a way that is most affordable and resilient to the consumers.
Low-carbon, high-density liquid fuels provide us the most bang for our buck. They're highly energy dense. We're not looking at massive changes to infrastructure, to engine technologies. We're looking for a way to drop in and replace conventional petroleum with these alternative fuels, with biofuels and other ways of making concentrated liquid energy from non-petroleum sources.
In looking at different renewable fuels, this is really the place to be. 50% of greenhouse gas emissions come from the transportation sector. Things like heavy-duty diesel, marine, rail, and aviation are really difficult to electrify. And so if we can provide sustainable low net carbon fuels in order to power those fleets, we can rapidly decarbonize the transportation sector.
It's incredibly exciting seeing the transition from combustion engines to electric vehicles and how transportation can become zero emissions.
We need partnerships with industry to prioritize the work that we're doing, to make sure that we are working on the most important problems, and to make sure that we're working as partners to develop these technologies in a way that optimizes cost and speeds the deployment.
The technologies that we're doing, if we can get them in the hands of people and get them excited about it, will make a big difference. And I think it's the most important thing anyone can work on. It's the biggest problem in society right now, and we're working hard on it. I'm optimistic that we are making a difference. We will continue to make a difference.